Come on. We did it. All right. There we go. Trying to think if there's any like gigantic space news that happened or anything interesting.
We had a break this weekend for a change.
Yeah. I'm trying to think if there's anything like beyond, I mean, obviously what we've got scheduled to talk about, but Starship has been quiet. NASA's
No
been
Mars helicopter flights.
Yeah, there hasn't been. They've got like a 6th flight planned. Like
no booster crashing.
Yeah.
How about sounding rockets out of Wallops? I heard something about.
Tonight. There is actually right after this show. I'm going to go to the roof and try to get it. It's Viper is the mission. It's an ionospheric. It's a suborbital mission. 9:15 they're launching.
Yeah.
But it's going to be after sunset, so we might see it right in the Chesapeake, Norfolk area here. We'll probably see it. They're quick. They're really quick.
Okay. I'm gonna say hi to some people. Hello to Fifth Dimension, Bob Kalo, Bob Muller, Coreyes, Cryptolicious, Frank Tippin, Froden Gautier, Hal McKinney, Ian Farquharan, Johnny J. Lionel L., Luke Wilhelm, Miguel Angel Romero, Nancy Graziano, Nifty, Rich Wilson, Ronald McCoy, Sir Grucy, Tom Van Scotter, and Zap and Zap. And hey, everybody. Who said this? Oh, Cryptolicious says, anyone else a dev? Anyone want to make a space token and NFTs for Fraser and Jean-Michel Gaudier and Christian and Tony and everyone else? Man, someone's going to have to convince me that NFTs are not a scam. That's the bar that you're going to have to climb over. And I'm...
It's fun to watch. It's like Amtrak. It gets you really, or Amway, it gets you really excited.
Yeah.
A lot of money out of it.
Yeah. The thing that I like about NFTs is that it allows the artist to maintain connection with the art and share in the upside of the art that they create as it increases in value, which is something that's kind of never existed for artists before. And so if you make something, you shouldn't be an artist selling your art and then dying in poverty.
We give away a lot for free.
Yeah, while people
like photography and
exactly. While people go and make bajillions of dollars, but it's definitely right now super overhyped and so I would not. And I like the idea of like you have like a members club. So like you do like 1,000 NFTs and it acts like a key that people can go and join some community behind the scenes, be able to participate in a community. I'm for that, but that's not an NFT. So anyway, I am skeptical. And I'm like, I totally understand crypto. I deeply understand it.
It took me a few minutes when I had first read about it to explain to my wife, because it's one of those things. I said the same thing. I'm like, so somebody's paying for a JPEG that's just online.
No, they're not paying for the JPEG. They're paying,
but that's what it sounds like when you first hear about it.
Yeah, I know. They're paying for a certificate to a JPEG.
Yeah, so it's like, how is that? And it's like, okay, it takes a while to digest it mentally to even regurgitate what the value is in that.
Yeah. So I need to see a thing that's used with an NFT that isn't just hype. And that's the part that I'm waiting on before I go, let's make some space NFTs. Sounds great. But I totally have the idea of artists being able to, or content creators being able to share in the upside value of what they create. I'm totally into membership communities and sort of like because I really am a fan of the idea of just focusing your efforts as a content creator on your community and not like trying to be everything to everybody. So
much of our stuff just gets put out into the wild now, and you're just like, all right, it's like photographs. It's just like anybody can share them now, I guess, because it's all out there.
Yeah, well, I mean, I give everything a Creative Commons license, which you may have noticed, Dave, on Universe Today. I hope you noticed that.
Yes.
Yeah. So I'm all for anyone using our content for anything whatsoever, even monetizing it. I don't care. But I can appreciate for other people, they want other copyright controls. But then this isn't that either. So anyway, I don't know. Convince me, Cryptolicious. I'm open. So what about baseball cards? Yeah, again, it's separated from the photograph and the certificate on the blockchain, the Ethereum. Anyway, all right, we should do a show. All right. I'm going to put you guys all back in your corners. There's me. What do I do? Ah, yes. All right. What's the date? 26th. Okay. Hello and welcome to the Weekly Space Hangout for Wednesday, May 26th, 2021. I'm Fraser Kane, publisher of Universe Today. This week, we're going to be talking about a lunar satellite constellation, another eclipse, last night's eclipse, Jupiter's moon Europa may have deep sea volcanoes, and more, maybe. Joining me this week on my screen, I got Dave Dickinson. Hey, Dave.
Hey, still here in Norfolk. Didn't see this morning's eclipse, but I was up on the roof to try to get the very beginning of the partial phase at sunrise. And we were right on that edge of that dividing line, but no luck. But I've seen a lot of lunar eclipses. They're not all that uncommon. They're cool, but you just have to be on the right hemisphere of the Earth to see them. So,
yeah, we'll get into the eclipse a bit and talk about that later on in the show and my failed attempt to see a lunar eclipse. So, we got Dr. Moya McTeer.
Hi, Fraser.
Do you know it's going to be you when I just say doctor and then with like a big long delay?
I actually could tell before you said doctor because you smiled and you were gearing up to say
it. That's my tell.
Yeah.
Yeah. All right. Don't play poker with me then.
Okay.
All right. We got Pam Hoffman. Hey, Pam.
Hey, Fraser. Nice to see you again.
Yeah, awesome. All right, before we get into this week's news, I just want to remind all of you that you should really go and join the Weekly Space Hangout crew. Weekly Space Hangout crew. They are our friends, our community, our fans, our executive producers. They call the shots. We do what they say. And remember, we're only a month away from going into our 2-month quiet period where we will be offline and you will have to just imagine episodes of the Weekly Space Hangout in your mind. And you can do that collectively with the rest of the people in the Weekly Space Hangout crew. So go to wshcrew.space. They'll hook you up. They'll give you everything you need. They'll throw you a lifeline to keep you sane over the long, bright, parched summer for space news. All right. Hiatus. It's coming. It's only 4 weeks away. Is that right? Is my math right? I think so. Maybe 5. Okay. All right. So joining us this week, we've got Dr. J. Nadeau. Dr. J. Nadeau. Is that right?
Yeah.
Good. All right. Welcome to the Weekly Space Hangout.
Thank you. It's great to be here.
So the question I always ask people, who are you? What do you do?
So I'm a physics professor at Portland State University, but I was previously at McGill University in the Department of Biomedical Engineering for 11 years. And previous to that, I was at JPL. So I kind of do astrobiology as kind of 30% to 30% of what I do. I'm a biophysicist interested in labeling and imaging. So crudely speaking, I turn things green. So find cells, turn them green.
That is awesome. I've seen some amazing pictures of things that have been turned green. What is the purpose of turning things green?
So there's all sorts of purposes. And so the astrobiology purpose is to be able to find cells in situ. So basically to find bacterial cells, even extinct ones, in rocks or in soil or in open bodies of water or in ice, all sorts of places where even just a few years ago when we couldn't turn things green, we didn't suspect that there were so many cells. And people thought, well, the ocean is very sparse in bacterial life. And it turns out there's hundreds of thousands of times more bacteria than we ever suspected.
Now, this idea of like fluorescence, is this done like chemically or is this done at the genetic level?
It can be both. And that's what's so cool about it. So that there's a lot of dyes that are just small molecules, just chemicals that you can add into a solution or onto a rock even, and they will bind with specific molecules on the cell. So this is a chemical labeling technique, and you can pick your dye that's going to target whatever chemical that you're interested in. There are also genetic methods, and this is the thing that won Roger Chen the Nobel Prize, is that he developed this gene called green fluorescent protein, or GFP, from a jellyfish.
Right.
It So it was this naturally occurring protein in a jellyfish that wasn't fluorescent, was actually chemiluminescent. He made it photoluminescent and then adjusted the spectrum so that it would be really useful in terms of, what kind of lasers are widely available, what kind of fluorescence filters, what the human eye can see really well. So basically he turned it from being sort of a cyan color to being very green. And so now you can genetically target this green fluorescent protein to basically any single gene that you want.
Now, this is a very productive method, as you say, for identifying life, different kinds of bacteria, just making it glow in ways that makes it very identifiable. How well has this technique been tested off Earth?
Not at all.
Not even on the space station?
Oh, on the space station, you can bring up cells. I don't think people have even done on the space station. In fact, there's a confocal microscope on the space station, but it has not had its wavelengths really tuned to biological experiments. So there's a lot of biologists that kind of disappointed that the material scientists got to use the confocal, but it doesn't basically, to get a little technical, doesn't have a 488 nanometer laser line, which is what excites everything you want to do in biology. So really hasn't even been done there. And so we have some proposals for experiments to go to the ISS that we hope get accepted, but so far the bacterial experiments there have been very limited. And of course, you're really limited too in terms of what the astronauts can do and what you want them to do, what they can safely handle. You don't want them handling something that will give you cholera or whatever when they're up there. So.
Right. So this idea then, to do this technique, you've got the dye, you've got the sample, and then you've got an enormous laser. How compact do you think you could make this instrument so that it could be taken safely to the International Space Station?
Yeah, so one thing you can do actually is replace lasers with LEDs. So that's a really productive area of miniaturizing microscopes that a lot of people have moved to lately. So more and more LEDs deeper and deeper towards the UV have become available just in recent years. So you can now get, a 10 milliwatt, 365 nanometer LED, and that'll excite a lot of dyes. You can really easily get a very powerful 405 or 450 nanometer LED. So that's really what you would do. Much more so than try to bring in argon ion laser, for example.
And it really sounds to me, my understanding of this, like this is the key way that you would be able to confirm fairly definitively of life on other worlds, Mars, Europa, Enceladus, places like that. So have there been any proposals in sending one of, this kind of setup to other worlds?
There have. Japan has come farther than any other country in terms of designing fluorescence microscopy suites for looking for life on other planets. So Japanese Space Agency has a really nice fluorescence microscope and sort of all the bells and whistles. So I would expect that they would probably be the ones to really do well proposing it for a mission. There's been a variety of other other proposals and other things developed in other countries. The US is a bit behind in this regard. There are a few kind of recent smaller NASA projects to develop various types of microscopy for space, but it's been kind of, you might be surprised, controversial. And there's been some degree of resistance to the thought of using imaging, I think, because there's kind of a view that it's maybe a little cheesy. You're looking for life by looking for life. It's too easy.
Right.
So, we want to define life as some kind of basic physicochemical thing and have some complicated matrix and do a chemical analysis. And people are very, very interested in knowing the biochemistry of another planet. And that's great. We do want to know those things. On the other hand, how do you know if it's biochemistry unless you first see it actually acting like life?
So let's imagine there was like a future sister to Curiosity and Perseverance that was sent to Mars, equipped with this kind of technique. How would the rover function? What would happen?
Right. So a rocky world is very different from an ocean world. So in an ocean world, you would have sort of a submersible microscope that would be similar to something like they have things called the flow cytobot now that just float in the ocean. Water passes through, it shines its illumination source, kind of tries to pick out things that looks like cells, take pictures of them, and make this database of these photos. And so you really can just do high throughput screening, basically, of volumes of water. In a rocky world, it's different. So there you would have something that would be, well, they do have, you know, sort of like the Molly hand lens and things on Mars. It would be like that, but it would have higher resolution. It would probably work in epi mode. So basically it would be reflective. So you would have light shine on the rock, bounce back, and you would collect reflections. And there is someone named Wolfgang Fink who's been developing basically multi-scale imaging for rocky worlds. What my group does is much more in the water ocean world sort of approach. We're interested in looking in liquids. But yeah, for rocky worlds, you're not going to be able to have, you know, a liquid sample flowing through your chamber. You're really going to have to go with opaque samples. Probably not going to be able to polish them. They're going to be pretty rough. So you really want to do everything in kind of reflection mode.
I mean, the advantage of going to a place like Mars is you're on the surface, while trying to go to a place like Europa, you have to get underneath 10 plus kilometers of ice.
Yeah, no kidding.
Which sounds a little tricky, a little of an issue. Although maybe, perhaps, you could capture some of this with some of the geysers that are already throwing samples out into space. Would that work?
That's really the hope.
Yeah.
And there's a hope that if you land close enough to one of the active cracks, that there would be enough traces of bacteria in the stuff that spewed out fairly recently that you would actually be able to detect signs of it. But of course, it is much harder than if you can actually access the ocean.
So then, I mean, imagine you've got your robot with a little cup or whatever with its little arm out over top of one of these geysers trying to collect samples as it's old faithfully throwing stuff off into space. I guess, are you imagining that the bacteria is spread everywhere, sort of in the same way that it is in the Earth's oceans, or do you think it would be a lot more rare in an environment like that?
So that's the billion-dollar question. The thing
that's about what that rover would cost. Yeah.
Yeah, and there have been a few papers that talk about the possible energy budget of Europa in terms of how many microbes you would expect per planet. It's hard to gauge, though, because we don't know, for example, if the microorganisms that lived on Europa could use, say, the radiation in the environment as an energy source. And if so, the energy budget is much higher than if you're just assuming they're going to photosynthesize based on the sun. So obviously, if they're based just on solar energy, it's going to be pretty sparse.
Right.
But we don't know if they're using radiation. We don't know, again, if there are possibly other energy sources, maybe deep under the crust, volcanoes, whatever they are, going on. So given our very crude estimates of energy budget, it is expected that life will be very sparse. But then again, even if life is sparse, it's probably going to be clustered. So you might have somewhere a geyser that's got 10 to the 10th cells per milliliter, and then 5 feet away, you've just got frozen ice with nothing.
Right.
And that's kind of how it is on Earth as well. So yeah, so actually finding your target, landing in the right spot, picking the right thing to look at is just as hard as figuring out how to look. And the same applies even on Mars, right? You have the special regions and you have areas that probably have liquid water, or if not, at least have ice that sometimes gets little puddles in it. And you have to get there. You have to find where those areas are and go there. And that's something that missions really haven't done yet.
And so ideally, you want to be able to get through the ice, send out your little submersibles, find the hydrothermal vents, find the European pompey worms, and sample them directly, because that's where they're going to be. If they're anywhere, they're going to be huddled around those vents. As we, one of the big issues that's really starting to reveal itself is how tricky it's going to be to get any kind of conclusive evidence over, some kind of life out there in the universe. And, we thought it was fairly simple things like, oh, you see oxygen, you see carbon dioxide, you see methane, whatever, then there's life there. And now it's really getting tricky to the point that no one's got a really conclusive answer spectroscopically. Do you think that the direction that you and your team are going will be able to inform people who are doing, say, exoplanetary surveys and not being able to necessarily, lick the rocks?
Yeah, I would say probably not. I think it's really hard to, I mean, one thing maybe we could discover is if there are, say, alternative bacterial metabolisms on Mars, we could find out if there's methanogens. So finding out for sure, for example, whether the methane on Mars is of biogenic origin would be very informative, because it would tell you if something like methane could be a biosignature on the planetary scale. Because as it is, even on Mars, we don't know. But in terms of actually confirming, I think we do need to be able to land and lick the rocks in a few places and have at least a few data points, because having just one data point on Earth makes it just so hard to be able to say what is a biosignature and what isn't.
Yeah, I mean, I sort of think about like even the controversy of what happened with Venus and the discovery of phosphine. It has been inconclusive, tending towards non-existent, but still, like, Venus is right there.
Venus is right there.
To imagine like firing up James Webb, looking at a world that is light years away and going, yeah, there's life there or not, seems it's going to be tricky.
I know, that's why I'm even a little skeptical of thinking about something like Titan, where, or even Enceladus, because if you're talking about 10 AU away, you know, we still haven't really explored Mars and Venus, and they're so much closer. You could just get to Venus in a few months. So you're not talking about a 10-year transit time. You're not talking about a 1 hour light speed delay. So as much as I would love to explore Enceladus, I'd rather go to Venus first, just because we would know so much faster.
Yeah, I mean, the more we're learning, like 20 years ago, this whole field of astrobiology didn't really exist, apart from some people, you know, pushing working on it in their spare time. And as this field has opened up and we've learned more about the search for life, what do you know? It's become more complicated, nuanced, and elusive than we thought as we're getting prepared. What do you think? Do you think we're going to find life in the solar system? How do you like our odds?
I am completely agnostic on the subject. I think we absolutely don't know. Give me one more data point. You can't even draw a line unless you have two, right?
Right.
So,
yeah. It's really tough. But we should look. Like, no matter what, we should definitely put in the effort to look. Yeah.
Well, have you happened to read Andy Weir's new book?
Not yet.
He posits without any spoilers, he posits a very exotic form of life entering our solar system.
Oh, interesting.
Yeah, so it's pretty good. I'm halfway through it.
Oh, I haven't read it yet.
Yeah, it's really good.
Awesome. Well, Jay, if people want to find out more about what you're working on and follow your research, where should they go?
Yeah, they should just go to my website, which is motility.pdx.edu. So
perfect.
That's the way to do it. And we have a lot of data publicly available, so that if people want to look at organisms and how they swim, that we're trying to just sort of make a database so that we have an idea of basically how all the different microbes on Earth swim, to inform things like machine learning for detection of things that are actively moving around if and when we start looking in places like Mars and Venus.
Well, and if you do find Europan space whales, please come back and let us know.
For sure. Yes.
All right.
Fingers crossed we actually send a life detection mission sometime in my lifetime. So.
It feels like it's time. We're ready.
Us too.
That's what comes after Perseverance. I'm sure of it.
Sure hope so.
All right. Thank you so much.
Thank you.
All right. Let's move on to the space news portion of the week. Dave, you're on my screen. Tell us what you got.
Well, first one I could talk about is the European Space Agency last week announced that they're going to have a consortium of two companies that is going to develop a constellation of communications / GPS satellites, like a network around the moon in the coming decade. And it's interesting in that, I mean, we have this network here, but they have this long range vision, not only for exploration, because obviously you could open up areas of the moon. There's a lot that we don't have direct line of sight to, like the far side of the moon never comes in line of sight of the Earth. The poles are kind of difficult to communicate. And those are the interesting areas we want to go to, because there might be water ice there. And there's a lot of the moon people don't realize we haven't explored, because the Apollo missions, at least on the ground, they only landed on the near side, and they were restricted to the middle latitudes, mid to equatorial latitudes. So we haven't landed at the poles. We haven't gone to the far side. But if there was a communications network / GPS network for location that was placed around the moon, about half a dozen satellites they're talking about doing, this would open up. And it's interesting, they have the vision that they want to open it up not only for exploration, but for commercial, for want of a better word, exploitation of the moon. Like if anybody wants to go there for any kind of commercial enterprise, be it, exotic things you talk about, helium-3 mining, or even launching CubeSats or doing anything else on the moon, the network is already there. So a small company, a small country, a startup space program, a private company doesn't have to reinvent the wheel to do this kind of network for communications satellites. Now, the time frame they're talking about is maybe a decade to get this whole thing up in place. But the first mission may launch next year. They're doing, and I always like how ESA does things, European Space Agency, they do things very thought out and measured. They do things like in 20 or 30-year increments, not very stop-start, but they're doing a Pathfinder mission for what they call the Moonlight constellation, is what this constellation is going to be called. Next year, they're going to be putting this in orbit to kind of have a test of concept. And the moon's going to become pretty busy here in the next year, too. We've got a lot of missions coming up. Capstone, that's going to launch out of Wallops here on a Rocket Lab Electron rocket. That is the Pathfinder for the Gateway mission that's going to go and orbit the moon for the Artemis initiative. But they're going to show with Capstone that they can do this unique polar orbit around the moon, insert something there, and actually have it orbit in the same orbit that the Lunar Gateway, the crewed Lunar Gateway, will be doing in a couple of years as part of the Artemis initiative. We have Astrobotics in their Peregrine lander. That's going up, I believe, on a Falcon 9 toward the end of this year. That's going to land. Intuitive Machines, they pushed their lander back to early 2021. We have the SLS. We're still crossing our fingers for SLS to launch. If you look at the schedule, it's still there in November for the very first Artemis mission. This will be uncrewed. It's going to do another flock of CubeSats to the moon, but this will be the very first Orion capsule, SLS rocket, the whole package that's eventually going to be putting astronauts back to the moon. They launched the Orion capsule a few years ago, but it was on a Delta IV.
Yeah.
So they did one up and around the moon to do the re-entry and do the testing and do all that as automated, another, again, uncrewed. I believe late 2022, 2023, they're maybe going to do the first crewed Artemis lunar orbit flyby.
Yeah, they're going to do an Apollo 8.
Yeah. It's a little depressing when you look at the cadence for SLS. I know there's a lot of controversy for this. They're talking about a launch maybe once a year or once every other year, and it's kind of like, come on, it's like Apollo. There were several launches a year, even the space shuttle, there were several. To launch every other year, I don't know if you're going to keep the interest up in it.
Come on. Come on. You know how this is gonna actually play out. We're gonna see one later on this year.
Yes, first one, uncrewed.
We'll see one 2023. Maybe we'll see the first Artemis, although,
I don't think we're going to have boots on the moon by 2024.
They've been signaling that's shifting as well. But, my thought is, SpaceX, if they step up with a Falcon 9 deep space.
Yeah, there's already they have a heavy rocket.
Yeah, and they have they've imagined a deep space Crew Dragon. I've mentioned this a couple of times in the past, that the internal space of the Crew Dragon is double the internal space of the Apollo capsule.
Yeah, and there's the European Space Agency will be doing the resupply missions to the moon and to the surface. But it's going to be, I hope I'm skeptical as always, but I hope this all unfolds the way they're, that if it does, that will be great. I'm all for going back to the moon. That will be great. I kind of wonder, though, if we all got excited when they did the Ares 1 launch and said, okay, the old Constellation program back in 2010, we're like, all right, there's a rocket on the pad. It's getting real now. And they axed that.
So did you know that in 2001, the Space Odyssey, the name of the rocket was the Ares 1?
I think I do remember that.
And the name of the capsule was the Orion.
Yeah, I think I do. I do remember that. Yeah,
so it feels to me like
Pan Am, of course, doesn't exist anymore.
Right, of course. Yeah. It's interesting. the moon is such a fascinating place, and it really feels like it's the right place for us to put a lot more of our emphasis. I mean, I know Musk wants to go and fly to Mars, but the moon is so close. It's right there. If you run out of toilet paper, you can send more in just a couple of days, as opposed to having to wait 6 months for the polar
And I would like to
Martians.
see them work out this whole idea. We always talk about some kind of automated machine where you throw rocks in one end and fabricated parts come out the other. We could practice that on the moon easy enough.
Yeah.
It's like, I would like to see that so they could start building, like, habitation modules and things like that.
It is interesting. I mean, I like your analysis of sort of the way the European Space Agency works. Like, when you look at the European Space Agency's calendar, they've got a bunch of big themes that they're going after. Planetary is a good example of this, and they've got they had Cheops, they have Ariel coming up. There's another one that starts with a P. Anyway.
Lisa Pathfinder was a good example.
Sure,
I mean,
and then leading up to Lisa, and so
the full up Lisa,
and so the European Space Agency seems very methodical. They set their schedule decades in advance and they stick to it.
Yeah.
While, say, the Japanese just kind of YOLO, robots at asteroids. I mean, and even what Jay was talking about, like, the Japanese have a pretty cool experiment. I could totally imagine in 2 years them saying, let's send some really interesting life finder to Europa or something like that.
Yeah.
And the Americans sort of, because of the changing administrations and the difficulty to maintain that
it is very
course.
Schizophrenic.
Yes,
Like we seem to bounce around from one administration. Now, I will say, you think about it, we're the only ones that have done the outer solar system. We're the only ones that have gone, being NASA, gone to Jupiter, Saturn, all these places beyond, because we have the funding to do those sorts of things. So NASA can do some great things when they want to.
Yes. Yeah. And then, of course, we have the Chinese being able to successfully put a rover down on the surface of Mars. I guess that's something else we should talk about a bit.
We had some images.
Came back. We finally have images. Pixar didn't happen in China, and then they delivered some pics. So
like 2 weeks
so
later, it's like it wasn't exactly like we didn't have a live landing like we were used to. But.
Yeah. All right. Thank you, Dave. Pam, let's talk eclipses.
Sure. Yeah, we just had one, and it was cloudy here. And it was like 4 a.m.
Yeah, for me as well.
Yeah, a little bit early. And I wanted to say something to Dave. I thought the Russians landed something on the side of the moon we don't normally see. Is that, did I understand that correctly?
The Chinese did Chang'e 5.
Okay.
4. Chang'e 4.
Yeah, I'm thinking like way back when, the Russians in the 60s maybe.
A lot has crashed on the far side, but the first
crashed. Okay.
The first intentional soft landing, I think it was early 2020 was Chang'e 4. Yeah, because Chang'e 5 was a sample return.
Yeah.
So
okay.
On the moon, yeah. I mean the
far side.
Right, but the Soviets landed a bunch of rovers on the moon. In fact, the last sample return that had come from the moon was from the Soviet/Russians in I'm going to say 19...
They weren't far side landings, so I don't
1976, I think they did a sample return. But no, it wasn't far side. Yeah, I don't think nobody's landed on the far side except for, I guess, Chang'e 4, but that's really the South Pole.
And China had to put a relay up in orbit to do it. They put a relay up at one of the Lagrange points in order to, similar to what ESA wants to do.
Yeah.
Okay, cool.
But what about the moon? Speaking of the far side of the moon, the dark side of the moon?
Yeah, well, the moon is an integral part of eclipses. We've got the lunar eclipse that just happened, and there is an actual, let me get my notes here. It's called an annular eclipse, and that's when there's the sun, and then the moon, and then the Earth. And in this case, there will never be a complete coverage. A lot of times the moon is in the right position to absolutely cover the sun kind of perfectly, and that's a total solar eclipse. This is an annular. It will have sort of a circle around it, and it's going to be kind of better than the last one. It's visible from northern and northeast North America. pretty much right before sunrise, 4:12 a.m. to 9:11. Of course, it's different, in different places where you are, but that's like Eastern time. And, because it is this still, ring of sun, you have to be careful and protect your eyes the whole time. Unlike a total solar eclipse where you can, in fact, remove your protection and look at it for just a few minutes while it's in totality. But yeah, please be careful out there if you go to look for this. And I'm not even sure if we're going to see anything on this side of the coast of the country. Do you know about that, Fraser?
Dave would
been
know.
really busy.
Dave will know. It's exclusively northeastern North America. The path of annularity is over. It starts over central Canada, over Hudson Bay. And I don't think the Canadian border is open right now. So a lot of eclipse chasers are kind of stuck between getting up there. Here in the Northeast, like Norfolk, we're going to see it, I think, as a 80% partial rising. So that's going to be kind of cool because for photography, you can get like things in the foreground with the moon. It'll be rising in partial eclipse. So I expect we're going to see some really cool like horns of.
Yeah, we were talking about the horns last time.
Up. That's all. Those are always very cool photos.
Horns. You lost me.
Like the sun will look like two horns basically rising as it's because you'll see a partial eclipse, the partial eclipse rising in progress. I got one a few years ago with the vehicle assembly building at the Kennedy Space Center in the foreground, and the sun was like only 10% partially eclipsed, but it still looked kind of cool.
So is it kind of like a crescent moon when it's, we just see the little...
It can look anything like a big Pac-Man kind of sun. The way I do those shots, the best thing is you're using like this setup with the DSLR and a tripod, zoom lens like 200 millimeter, and a neutral density filter on the front.
Oh, cool.
So you're not looking through it. It's not, neutral density isn't good enough to look at the sun on its own, but photographically, if you have it dialed down to a really fast shutter speed and ISO, you can get some pretty good. It'll be enough to get the foreground, but the sun as well in there. So
and I gotta learn that stuff, but it sounds expensive.
Yeah. The trick, like I said, is you're not looking through the viewfinder at the sun because an even neutral density is not going to be enough to stop sunlight.
You want to look at it directly yourself anyway. So
yeah.
So a couple other highlights, and there are like a dozen conjunctions. I'm going to put those on the website after the show posts. But yeah, we've got last quarter moon on June the 2nd. We've got a new moon with, like I said, the annual eclipse. That's June the 10th. All right, so we got a little bit of time to prepare for that. Of course, Father's Day is the 20th, and the summer solstice. That's always good because, of course, the sun is at the top of its arc, on the Earth, that kind of thing. And I was wondering about this one. Is this significant? It says Mars crosses the Beehive cluster M44. That's June the 23rd. I didn't really understand why that was part of and I use the Old Farmer's Almanac. Let's see if we can.
Oh, it does that every few years. It's always cool to see.
Okay.
Like you'll just have Mars in front of its Messier 44, like open cluster. Kind of nifty.
Oh, okay.
I have
All
seen
right.
that before.
It's not foretelling the end of the
Oh yeah, well,
or bees,
none of the stuff.
like a lot of bees. Yeah.
None of the stuff really is. It's all solar mechanical stuff. All right. So June 24th, we got the full strawberry moon. It is a super moon. We've had a bunch this year, and a lot of people don't quite understand that. It's just the moon is a little bit closer, and it's I think 4% bigger. But I've never been able to tell. Do you have to use like photographs to kind of compare?
Side by side, you can see the difference. It's not much.
Right. Yeah, it's not something I ever have noticed, just looking at the moon. And we've got, and this is kind of cool. On June the 30th, we have International Asteroid Day. And I think that's the thing that Brian May, who is a guitarist from Queen, the band Queen, has been really involved with lately. And of course, it's, how to protect ourselves from asteroids, especially the ones we cannot see. The next meteor shower is in July. So I'll talk about that on the next show because I'll be on June 30th.
And of course, preview the best meteor shower, which is going to be the Perseids. But that's August.
August, yeah.
Right. Yeah, that is the best one. This one's kind of 10 to 20 out of Aquarius. Peaks July 29th. But I'll talk about that more.
Yeah, no spoilers. No spoilers.
No spoilers. Yeah.
All right.
Thanks, Fraser.
All right. Moya, what do you got for us?
I'm going to stick with the theme of moons, but instead of talking about Earth's moon, I'm going to talk about Jupiter's moon, Europa. So Jupiter has 79 moons that we've found so far, because it's greedy. And one of those moons gets more attention than the rest because it's long been considered the most likely to host life of Jupiter's moons, and that is Europa, which we've been talking about a bit tonight. Europa is just a little bit smaller than Earth's moon, and we've known or had a pretty good idea since the 60s based on ground-based observations that the surface of Europa is likely a thick sheet of water ice. Observations both on the ground and in space since then have made scientists increasingly more sure that there's a subsurface liquid water ocean. Those observations have, looked at the magnetic fields around Europa to see that there's something is causing this strong magnetic field. Maybe it's a bunch of salt water underneath the surface. They can also see these cracks in the ice on the surface that look like jigsaw puzzles, like they fit together and they move around. And if they're moving, like what's under them causing them to move? But the best estimates say that the ice sheet itself is between 10 and 15 miles thick. Fraser, you can do the conversion to kilometers if you want.
Like a little more.
Okay.
Yeah.
And then the ocean underneath that is between 40 and 100 miles deep. And for your reference, the deepest part of Earth's ocean, according to the NOAA, is less than 7 miles deep. So this is a big ocean. There's a lot of space under there for stuff to happen.
So sorry, just to stop you. One sort of interesting idea, there's this idea of water worlds that the deeper the ocean gets, you get to a certain point where you have no mixing of the bottom layers of the nutrients making it into the upper layers, and so you would essentially have a lifeless upper ocean, but possibly a richer. But then if you get that sort of the density of the water coming in down on top of it, that you've sort of got nasty conditions. It's either no nutrients high up or really dense water, almost like acting like ice farther down as you go. So but you're going to talk about volcanoes though, so that might make things better.
So that was just like some background info about Europa. So the study that came out last December but was written up earlier this week, the study was in the Geophysical Research Letters, that journal. The study looked at the possibility of volcanoes at the bottom of Europa's ocean. And the best understanding for why Europa can have liquid water underneath the surface of the ocean is from tidal stresses. So gravitational pulls from Jupiter and the other moons in the system stretch and contract Europa over and over again. And that causes friction and that causes heat. And a team led by Marie Behunkova in the Czech Republic modeled in detail these tidal stresses and found that they might actually be enough to generate not only enough heat to melt the subsurface ocean and make sure that it stays liquid, but also enough to melt the upper layer of Europa's mantle. And if you have a melted mantle, then that could lead to volcanoes. And this is really exciting because sustained volcanic activity on Europa would make it maybe the only other world that we know of with enough water and abundant energy to maybe host life, which is something we're very interested in finding. The study did find that if there is volcanic activity, it's most likely to happen near the poles of Europa, because that's where the heat from these tidal forces is most intense, according to their models. But they're going to need more data, more empirical data of what's going on under the surface. So the Europa Clipper mission from NASA will be really helpful, launch in 2024, arrive in Jupiter's orbit in 2030, and it will have a thermal detector so that they can measure the heat differential on the surface. If they find a big hot spot, then maybe they'd be able to see that there's a volcano happening underneath. They're also going to be able to measure differences in gravity over the surface of Europa to see if maybe there are dense or underdense regions in the mantle that could tell us more about whether or not there are volcanoes there.
I mean, volcanoes is next level. I mean, we know that Io is the most volcanic place in the solar system, and it's just one moon in. And obviously, we know there's some kind of tidal interaction, some kind of tidal flexing that's happening that's keeping Europa liquid, and possibly hydrothermal vents, but full-on volcanoes?
Yeah. I mean, I didn't do the modeling myself.
You didn't peer review this one? No.
I did not. I've actually never peer reviewed a paper. Maybe I should get on that. But I mean, if the tidal stressing is intense enough that the mantle is melting, why not?
But I wonder then, sort of back to what I was talking about earlier on, this idea that if you've got what would be an impenetrable layer of stagnant water, how, we think about volcanoes on Earth can drive plumes of ash tens of kilometers, tens of miles into the upper atmosphere. Could a similar process be circulating nutrients and heat in the European Ocean to feed the European ice whales?
That's a really good question, because there are a few things you have to consider. The pressure from the depth of the water, but also the temperature, which will have these really interesting gradients if there are volcanoes. So if you have a volcano, then maybe that heat source will make it easier to distribute the nutrients from the volcano. But I also want to bring up the fact that there are going to be salts and nutrients in the sheet of ice at the top. So I don't know if it would be totally dead up there.
Well, that's the question. I mean, I know that there's some concern with terrestrial planets like water worlds where they are warm and the water is entirely liquid, that there's a real concern that you get below a certain point and the water becomes really dense and the amount of pressure gets too high, and at the same time there's no ability for the life to mix in. I have a dog here. So it's interesting. So, I mean, I guess what if we push farther out into the Galilean moons? Do you think we could extend this idea out to Ganymede, to Callisto? Because Ganymede is the new Europa, in my opinion.
Is it? I don't know much about Ganymede, actually.
Ganymede is awesome. Ganymede has everything going for it. It's got a liquid ocean underneath. Sure, it's thicker ice shell, but what are you going to do? It has a magnetosphere.
That's its own magnetic field.
It's the only moon in the solar system with its own internal magnetosphere, so protection from space radiation. It's far enough away from Jupiter's inner field that it also isn't being bathed in radiation in the way that Europa and Io are. So, yeah. In fact, European Space Agency totally agrees with me that the JUICE mission is going to be spending a lot of time at Ganymede, because it really is. It's the new Europa. I think if I could buy stock, it would be in Ganymede, not Europa. Yeah. Europa's tired. Ganymede is wired.
Ganymede and Callisto, humans could probably go and exist and not die within half an hour.
Right. Yeah, exactly. Yeah. I think if you're on the
with spacesuits, of course.
Yeah. No, if you're on the surface of Europa,
you get a lot of radiation.
You have a 50%, I think you get 1,800 times more radiation than just space itself because of the trapped radiation from Jupiter. And you've got a 50% chance of mortality within the first 30 days. Yeah.
It's not a fun place.
Yeah.
Does that cut through the ice?
No.
I don't.
No,
think
1 meter
so.
of ice, you're fine. Yeah. If you could like hide under a meter of ice, pull up ice blanket over top of you, you're totally safe.
Those are tidally locked too. So what I've never seen is, would you be okay on Europa's far side? Would that shield you?
No.
Or is there would still be enough channel back there?
Yeah, no, you're buzzing through this giant donut of space radiation. So no, that's not good. But yeah, no.
But Ganymede is where it's at.
But Ganymede is where it's happening. Yeah. So we need to. So wake me up when we hear about volcanoes on Ganymede.
Okay.
I will. Yeah. All right. Well, we're closing in on the end of our show. I want to give everyone a chance to let us know what they're working on and where people can find out more. Moya, you're still on my screen, so why don't you tell us what you're working on and where people can find out more?
Sure. I am working on my podcast, Exolore, which is all about fictional world building, but based on facts and science. I just released an episode about the world building of sound design. Now you can use that to build cool fictional worlds. And you looked confused.
Yeah. Like, what? Please, I'm going to need more.
Well, the point of the episode was that sound designers are building worlds. They're building soundscapes, and that's an important way of how we experience different fictional media. Like you can watch a scary movie with happy music, and it's not scary anymore. So sound design is really important in some types of world building. So that's one thing I'm doing. I'm also working on a book about the history and evolution of the Milky Way galaxy coming out next year sometime.
What?
And you can.
That's awesome.
Yeah.
Have you got a name for it yet?
Not a name that I love. Right now it's called The Milky Way, an unauthorized autobiography, because I'm writing it from the galaxy's perspective.
That's fantastic. I love it.
That's tentative. Yeah.
I can tell you that the name and the picture on the front of the book is always the biggest battle with the publisher.
Yes.
They don't seem to care too much what's inside.
What's
the title?
It's
the title of the book and the picture on the front. That's always what they want to change.
Isn't that kind of how I roll with Universe Today as well? So yeah, I think it's probably the same everywhere. Yeah. So the point is like really nail that title, and then you don't even need to write a book. You'd be all right.
Oh, okay, good.
Yeah.
I wouldn't get too invested in it because, like I said, they may want to totally scramble the title at the last minute.
Yeah.
I'd honestly be very okay with that. I'm not wedded to this title at all.
I think we spent more time talking with our publisher about the picture on the front than the rest of the book combined. Yeah, the days got behind him.
Well, you remember, Fraser, that this book they wanted to put it was a fake photo. It wasn't even. It was one of those, like, any amateur professional astronomer would look at it and be like, "That's totally a fake."
Yeah.
It was like,
You fought that, right?
We fought it
They
hard.
cannot put that.
Yeah.
It's like I'm open to most suggestions, but it's like they cannot put that on the top.
Yeah, I
cover
like
of the book.
anything they wanted. I just rolled over, and then we were like, "Yeah, but what about this?"
most things.
Yeah, most.
I give up on most things.
Yeah, we totally rolled over it. But that cover picture, we were like, it's got to be taken not by the Hubble Space Telescope. It's got to be taken by like a really good amateur, the kind of picture that a regular person can take with patience and gear and technique. And we've got to pay the photographer to use
that was the same with
picture.
this one too.
Yeah.
This was an amateur photographer in Peru took that actually.
Yeah.
And they're always thrilled to get on the, they get paid, but they're always, I like doing that better than having something that's just like a public domain NASA photo anyway.
Yeah.
Makes it better.
So whenever negotiate a gigantic photography budget, and then I'll hook you up with a whole bunch of really great amateur astrophotographers who would be grateful to get paid for their photography, and you can have pictures in your book that nobody's ever seen. That's the way. Yeah.
I was thinking of making it kind of cartoony, almost as if it's like little hand doodle drawings of things.
That's cool.
Yeah.
That'd be cool.
Yeah, that's awesome.
Yeah, I'm excited about it.
All right, Pam, what are you working on, and where can people find out more?
So we are showing, live Friday nights live. We have a show. And in fact, Dave Dickinson is going to be our next guest. However, we taped that show because it's very late where Dave is on Friday nights at 9 p.m. Pacific time. So yeah, we're available on YouTube and our Everyday Spacer Facebook page. So that's a good place to find us. And of course, replay afterwards. I actually created a workshop I'm going to be offering for the first time on Sunday. It's called Find Constellations and Stars in the Night Sky. A lot of people have been like, I really want to know how to find stuff in the sky, and they don't know a lot yet. And I hope to build a really nice foundation, share what I've learned since 1991, and really help them to, have a lifelong experience, happy under the stars, that kind of thing. So that'll be Sunday, and again on Thursday. So.
Fantastic.
That sounds nice. I feel like I need that workshop. I can't find anything.
Yeah, I can help you.
Yeah. All right, and Dave.
Frequent contributor on AstroGuys with a Z on Twitter, frequent contributor to Universe Today, longtime contributor now at this point, Sky and Telescope magazine, and Astro Gear Today. That's a new one I picked up in the past year. First book with Universe Today. second book. It's been out for a year now. It's doing fairly well. And I'm writing about, the next thing I'm going to write about is probably the annular eclipse for Universe Today, a complete guide to everything about how to see, how to photograph the annular eclipse. And in about 5 minutes, I'm running up to the roof to watch the Viper launch out of Norfolk.
Oh, cool.
Looking at their feed on Twitter right now, it looks like they're still going. So
that's awesome.
Yeah.
Oh, bravo. Last one took forever.
I know that one, it took them about a week because they needed very particular conditions to launch. Yeah.
I see.
This one, I don't think it's particular.
Cool. All right. I'm going to put you guys all back on the screen. There's everybody. Thank you, everybody, for joining us this week on the Weekly Space Hangout. We really appreciate it, and we really enjoy having you come along this journey through space with us. Thank you to all the moderators who are sort of operating behind the scenes. Special thanks, as always, to Nancy Graziano for keeping us all organized. She's got some big plans for the final month before we go on hiatus, so definitely stick around, especially the last show should be fun. And thank you to our special guest, who is still sticking around, I guess, muted. Hi, Jay. Thank you for joining us this week, and we will see all of you next week. Thanks, everyone.
Good night.
Behind the button.